Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome in, everybody, again to another episode of Weathered Questions, the podcast where we answer the meteorology questions on your radar. I'm meteorologist Kai O'Mara, joined by meteorologist Jan Kaj for yet another episode here in Season 5. It's all about your weathered questions, and we've been getting not just personal conversations about this, but email questions in too. We welcome that. weatheredquestions@gmail.com to join in the conversation. Jan, how's it going today?
It's going really well. You know, things have been picking up for summer in terms of all the fun stuff, and looking forward to some vacation time here coming up soon. So yeah, things are really good.
There you go.
How about you?
Same. Summer camp. The grind is going. It's a different kind of grind. It's a little more of a flexible grind, which is nice. But field trips are happening. We've already been to the pool once, so good times.
Nice.
It's good stuff. That's what we want.
It really is. Yeah. So we've, been talking quite a bit here over the last several episodes about some more dramatic weather maybe that we have had or that we typically get. But one of the things that we wanted to start off the show with today was a thought we left you on last time. And that is those kind of more cyclical weather patterns, or why you might get repetitive weather. Why you might have 2 weeks of dry, and then all of a sudden you have 2 weeks of just insane rain that just doesn't stop. And maybe there's a month where every Monday is sunny and every Saturday is rainy, and you can't, you're stuck at work when it's nice out, but you've got the weekend off and it's all cold and wet. A lot of people observe those things, and we wanted to talk a little bit more detail, kind of as a follow-up to last episode, of why that happens. So take it away, Kai.
Yeah. I mean, there are some times when it's just a matter of bad luck where we get stuck in a stretch and we can't break out. We call those blocking patterns. But if that's not happening, there was a saying a long, long time ago. It was right when I first started in TV that I first heard about it, but my parents knew about it. So it's been going on a long, long time. If it rains on Easter Sunday, it's going to rain every Sunday after that. Mm-hmm. And, that's some years it gets kind of like that. And Easter is, of course, in the springtime. And we don't tend to get what we call a whole lot of blocking in the spring. It tends to go up and down. And we tend to associate spring months in the United States with snow is melting, but we can also get some extremes. And it doesn't tend to stay the same for very long. So that could have been where this entire saying originated from. But at the same time, this takes us back to college, and you had to do the same thing I had to do. But I had a feeling that I had to probably use more pencil with it. Maybe you had a little more electronics than I did. But in one of our dynamics classes at Iowa State, we did something called the WAVE project. And I'm sorry, it was so boring. And I wondered, why in the world are we doing this? Well, so here's what we do. We would look at the top of Earth, basically. Imagine you're looking straight down on the North Pole. The pole is in the center of your screen. And if you're looking straight down on planet Earth, it looks like a big circle. And it goes out to the equator. And what we would do is we would draw dashed lines where we see dips in the mid-level winds. We call those troughs. And we'd track that every day in class for a semester until we could figure out, what do these mean? Like, what winds up happening? So it turns out there's some predictability there. And it depends if you've got maybe 3 waves or 4 waves or 5 waves, and how timely might they be based on what we call the amplitude, or how high they are, how deep they go. And sure enough, yeah, it takes about 3 to 3.5 days for a wave to move across the U.S. from coast to coast. If you think about a large storm up in Seattle, assuming that we're going at a constant general speed, it might wind up in New York about 3.5 days later. Well, what's 3.5 times 2? 7. So it might not be exact, but there was a time, I think it was the final year or two I was in TV, when we had, I think, rain every Thursday for 8 or 9 straight weeks. And it was to the point where even radio hosts were seeing this, and they start emailing me like, is this a thing? And you could count on it. Like we were just joking about it. 9-day forecast. There's always going to be a Thursday in a 9-day forecast. Always. If not 2. Just put it out there. And lo and behold, it verified. Now, that being said, we had natural rises and drops in temperature. But it was probably because we had a remarkably stable and predictable type of wave pattern at our steering heights, as we call them, which is about 4 miles high in the atmosphere or so. But if we ever get something weird, like a huge high pressure ridge over Greenland, that all of a sudden it's like a bus breaking down in the express lane, the whole pattern stops. And then it all gets messed up. And then you can just forget about the cycle till next year. That's pretty much how it works. But that's my take on it, Jan.
I think that class, that class is one that, like you said, like when you're going into it, you're like, why am I doing that? And you do it for every day.
Mm-hmm.
And it's not the most exciting thing, but the amount of times that I have referenced back to it after the fact, right? Where, you're talking about like, oh yeah, the cyclical waves and how everything plays out, and kind of like throughout the semester as you're like kind of coming to those realizations as a student, it is kind of a fun, maybe retroactively. I recently learned about type 1 fun, type 2 fun, the different, like when you're having fun in the moment versus when you're having fun after the fact.
Oh,
yeah.
Yeah. True.
Yeah. So it's kind of like that. We're like, in the moment, like you're like, this is the most boring thing ever. But like after the fact, I'm like, okay, this applies to a lot, and I bring it up very regularly. I also had a different teacher for that class, so I don't know if that played into it either.
That could have played into it. That definitely could have played into it.
Yeah.
But yeah, and the thing too is, I'm sure we've all heard this mentally or felt it mentally, like maybe we've had just a streak of good luck going. Oh, geez, we're due for something bad, or we're due for this to turn around. Like if you watch a professional sports team, they've lost 5 games in a row. We're due for a win soon. If you got 2 straight weeks of warm temps, you can't stop the cold air. It's coming. That's why I always caution people in December. A warm December usually means you're going to get pounded in January. Not always, but usually. It's kind of like holding that weight bar above your head as long as you can. And then eventually you drop it, which is why we've got spotters in weight training, because you don't want that to hit you. But in the atmosphere, I can't tell you how many emails I get. Are we just going to skip winter this year? No, that's not how this works. We're not skipping winter. That's physically impossible. It's coming. We just may not know exactly when. So those long blocking patterns are typically equal and opposite by the other type of block.
Yeah.
So just something to be wary of as you go forward. Like if you're dry for a month, that next month might get really wet in a hurry. That's how it can work.
And you mentioned kind of that old adage of if it rains on Easter, it'll rain for 7 Sundays. Mm-hmm. I pulled up, we have a little folklore kind of bank that we have that I had put together. And there's a couple other ones that are kind of related to that again, if you think back to this math and the science that we just kind of talked through, rain on a Monday, it will rain for 2 more days that week or 3 Mondays in a row. Again, that kind of works, right? The 3 Mondays in a row, that back to that 3.5 times 2 thing. If it rains on the first day of the month, there will be 15 days of rain during that month. So again, if you kind of space everything out, again, these are mm-hmm. old folklore sayings. They're not always going to come true. Though. It is, right?
I kind of want to look that one up now.
Oh, there's a whole bunch of them in here. Those were the best ones for this, for that cyclicalness. But there's, if you cut onion rings and stew salt on them, and the amount of moisture that they accumulate overnight is how much rain is ahead. We should try that one. We should see what happens with that one. Yeah, that's in here.
They wouldn't last the night. I would eat them. Sorry, experiment. They're gone.
Yeah.
It's not even close. I've never heard of that.
I hadn't heard of that one either.
One. It has to be a humidity one.
Exactly. Yep. Yeah. So there's some fun stuff that we could get into the folklore stuff maybe here in the future a little bit more. But there's definitely, these are things that have been kind of stood the test of time, where everything's cyclical, everything kind of repeats after a few days. So,
Well,
yeah.
and June has been, no stranger to severe weather. It kind of had a slow start when it was dry. It's been very active since then. And so this is a real quick one that comes in here. And I'm just going to introduce it to you. Why don't funnel clouds always reach the ground? Why do rotating clouds not always produce a tornado or a funnel? What do you think?
Well, I could answer this really short and say, we don't know.
We don't fully know. You're exactly right. Yeah.
That's the long and short of it is the tornado science, tornado genesis, which is, as it sounds, the start of tornadoes. That is still kind of the biggest question mark in meteorology and the biggest thing that is being researched. That's why storm chasing is such a big deal and why so many people love it and are obsessed by it and are interested in it, right? Because there is a lot to learn in why tornadoes happen or don't happen. That said, we do know quite a bit of stuff about it. And the scientific process is a beautiful thing where you research something, and even if you get, well, that's not the answer, that's one more piece of data in your toolkit to say, okay, well, this isn't the reason, so it should be something else. And so with all of that research, with the years of research on that, with all of the meteorology research and chasing research and stuff, long and short of it is what we can deduce right now is that something's missing in terms of the ingredients. We've talked about this on episodes before where for, let's say you're making a cake, you're making a tornado cake and you need the exact right amount of sugar and the exact right amount of soda, baking soda and eggs. And if you put way too much, baking soda in, something is going to mess up, the chemistry in that cake, and it's not going to turn out right. And that's exactly the same thing with our atmospheric ingredients, with our energy, our CAPE, with our moisture and humidity, with the wind shear, all of those things where something just doesn't come out quite right, where it's enough energy or enough rotation, enough wind shear to get the clouds rotating, but just not enough to stretch out that tornado to get it down to the ground. That's the best way I think we can put it right now. And that's the beauty of science and the beauty of research and why this field will continue to grow.
Yep. And you also have to remember, whenever these warnings come out for tornadoes that say Doppler radar indicated, that's a great thing. What the radar is detecting is rotation aloft. It's not actually detecting a tornado anywhere. It's detecting what the air is doing at whatever its beam height is. So to your point, Jan, if we got a funnel cloud, I'm going to guarantee you the radar cannot see that.
Yeah.
I'm going to guarantee it. What it's seeing is some rotation much farther up, maybe 2,000 feet higher. It can't see the funnel cloud unless you've got a Doppler on wheels or a Dow unit that's right there next to it. And there are some researchers that have those. I've seen them at conferences. They're beautiful. They're awesome. Unfortunately, we don't have very many of them. And you kind of have to be at the right place at the right time to use it. But some of the data they can see is ridiculous compared to your standard NexRad because it's a general limitation of the tool. And so there is a whole lot under there that we don't know. And also, unless the air is moving something or condensing, you really can't see air moving on a windy day. You know it's windy because you're feeling it, and you know it's windy because stuff is moving, but otherwise the air is invisible unless it's carrying something or it's condensing. So you're right. There's a whole lot of unknowns there for sure.
Yeah, all that research, it's expensive, it's cumbersome, and it does take a lot of energy and resources. So, all the more reason to keep funding scientific research and meteorology research. So with that, talking about tornadoes, talking about funnel clouds, if you remember last season, we did a cloud a day or a cloud a week, cloud a day, cloud an episode, we'll call it.
Yeah, cloud an episode. There you go.
And so we're going to do some review today and see how well everybody was listening. So what is the name of the cloud feature that a tornado originates from? Is it a shelf cloud, a roll cloud, or a wall cloud? Again, the name of the cloud feature that a tornado originates from. We'll give you a few seconds to think about it. All right, we're back. Play and review today, pop quiz. What is the name of the cloud feature that tornadoes originate from? Did you think it was the shelf cloud, the roll cloud, or the wall cloud? I know you know this one, Kai. I'll pass it off.
Bump. It's the wall cloud.
You need to record that little bit there and play that every time.
It's the wall cloud, which then your funnel can come from there, which then if it touches the ground, a tornado can come from there. Wall clouds are usually an issue. And if the wall cloud itself starts spinning, now you really have an issue. That's the kind of stuff, actually, that the National Weather Service, when they go through the spotter training guides, they really want to know that kind of stuff, because they're at the office. The radar cannot see the wall cloud level. It cannot. It overshoots it every time. And so to have a spotter on the ground saying the wall cloud is stationary, that's good to know. Maybe it means the rotation isn't as great as it could be. Or now if the entire wall cloud is spinning, well, that's a problem. I mean, we should probably continue the tornado warning at that point. They'd probably continue it anyway, but that kind of stuff is super important. And then
sign of a really strong storm, basically.
Yep. And then from there, you can get your tornado to drop down. Absolutely. And then that gets you, kind of in the watch and warning process. And when I first started in television, we did what were called county-based warnings. And what that means is, and the funny part is, there's this county in Nebraska. I don't even know its name, but it's huge.
Oh, I probably do. Where you at?
It's whatever that one is in the western half of Nebraska. That's like the size of Rhode Island. It's huge. And you'd see a fifth of Nebraska light up for an isolated storm, because that's what they had to do. That's what the technology allowed.
Oh, Cherry County. We're talking about Cherry County. How could I forget Cherry
County? The big
one? Oh,
yeah, the big one. And you'd look at the Weather Service map and go, what in the world is going on there? It's like a bomb went off in there. No, it's just an isolated storm. And it's like, well, certainly we can do better than that. And the answer is yes, we can. In the late 2000s, we went into something called the polygon warning system. That's why all these warnings have a weird look to them now. Some of them are triangle shaped. Some look like trapezoids. A lot of them kind of look rectangular, or if you were to squash a rectangle with a wheelbarrow or something, you wind up getting this weird looking thing. And the reason for that is what the Weather Service is trying to do there is pin in the threat a little tighter, as opposed to warning the whole county. Now, I don't have a bar of soap nearby, but this is soapbox time. Okay. The biggest thing in the educational campaign very early on in my career was watches versus warnings. Do we know what they mean? A watch means conditions are favorable. A warning means it's imminent or occurring. Key differences. But then what'll happen is a warning comes out. And depending on how you have your app set, or depending on how anything you have is set, you might get an alert for a severe thunderstorm warning, but you're not actually in the warning. So for example, let's say your city is in the northern half of a county, and the southern half of the county goes under the warning. It hasn't rained at your place yet. You just got an alert for a warning. Do you take action? Are you in the warning? Are you not in the warning? And one of the big key components about the polygon system was to reduce the false alarm rate, as we call it, because you don't just want to warn and nothing happens. But then number two, let's reduce economic loss. Because one thing you can think about, if something were to happen at your workplace, Jan, for example, my workplace is my own house. I would dictate my own rules. And my own rules is I'm in the basement anyway, so I'm good.
Fair.
I'd probably still want to know about it, but I'm good. I'm not going anywhere. If you work in an office building, your workplace might have a policy.
On the third floor, right next to a bunch of windows.
Yeah.
Yeah.
Your building probably
don't want to
has
be there.
A policy.
Yep.
And at that point, now you've got to take action. But what if? What if the policy that's in place isn't taking advantage of some of the latest things that the Weather Service is offering? And I think that's something for everyone to think about, because the last thing you want to do is false alarm. And we've seen this with sirens too.
Yeah.
And that can be really frustrating for the public.
Yeah, it really can be. And I think those are very commonly misunderstood, right? About that so many people will say, oh, the tornado sirens. my soapbox moment.
Yep. I put the bar soap down. You get it now. Go for
it. They are called outdoor warning sirens because they are meant to warn people outdoors of warnings, of things that are happening, not only tornadoes. Yes, they are excellent for tornadoes. And anytime the outdoor warning sirens go off, you absolutely should pay attention and act as if it was a tornado, but it's not always going to be. It could be large hail. It could be strong winds. Most counties, most municipalities do have some sort of threshold for that these days. That has become even more apparent in the last 5 or so years that there is a realization of, oh, we do need to warn people about severe level wind or about large hail. And so just because the tornado sirens, the outdoor warning sirens, just because those are going off doesn't guarantee that there will be a tornado, but it does say, hey, meteorologists are expecting some bad weather in your area, you should take cover. That also does come with the stipulation of some counties, again, depending on where you are, you have to be familiar, just like you have to be familiar with your city codes on what side of the street you can park on. You should be familiar with your city or county siren warnings, because some of them will do it for different thresholds. So maybe if you're on the county line or near another city, you might be able to hear other sirens, and so maybe you're hearing them for different reasons. Maybe one has a 65 mile per hour threshold and one has a 70 mile per hour threshold. That's entirely possible. Sometimes some places won't do them for hail. Maybe hail just isn't common where you are. There's different reasonings, and so it's just good as a consumer of weather information, as a person in the public impacted by weather, to just be aware of what's happening. And those phone alerts that Kai mentioned, wireless emergency alerts, we've kind of become more familiar with them. Whether you have a weather app or not, you can get, obviously, a weather app that you can program and say, I want to be warned for my location or this town or this county, which is great. Just know kind of what those settings are and how you've adjusted them. But there's also those wireless emergency alerts that are innately in your phone that go off of cell phone towers. And so maybe if the nearest cell phone tower to you is under a warning, but you happen to be further north of that, but your cell phone data is still coming from that tower that's in the warning, you may still be okay, depending on, again, where you are exactly and how far away the next tower is from you. All of those things are basically just there to say, hey, you should probably get to a safe spot. I want you to be safe. And then you should look and check what's happening and where that information is. But it's better to do it that way than the reverse order of, I wonder what's happening, and spending 5 minutes trying to figure out what's going on and if you're actually in the warning or not, and then losing that 5 minutes to where you could have been in your safe place, because sometimes time really matters. And that's, to your point, Kai, about the false alarm rate and stuff, trying to reduce or increase that warning time and reduce the amount of injuries and deaths because of that has also been a very important project here recently.
Yep. And one, I think, closing thought on this is going to be, everything moves along typically because something's happened in the past to make it a policy, or, we had some type of tragedy that would happen to make this a new thing that we're working on. Be especially careful if you're camping, because as we go through the summertime, you've got scout camps going on, you've got family trips going on. At least check the weather before you go. And,
Please.
One of the big things about outdoor warning sirens is you are now the target of why they're made, is when you are out in that camping situation and when storms do roll in and you are on that baseball field. Because let me tell you something, a tree that falls is a lethal weapon. We've seen it happen before. And we've had folks that die in camping incidents because a tree falls in their tent.
A camper will not protect you.
Right. It happens every single season in the Midwest. And so make sure you got plenty of ways to get your warnings. And again, if the outdoor warning sirens are blaring, it probably means something's coming in. So get your next level of information at that point. And more importantly, get yourself to a safe spot.
Absolutely. Again, safe spot first, then the more information thing, always the best course of action. We preach a lot of safety as meteorologists. That's just kind of our job. We want everybody to be safe and informed. If you feel a little bit of either after this episode, we're so glad that you spent your time with us here today. If you learned something, if you'd like to join in on the conversation, ask us a question, maybe something that was sparked from today's conversation, please feel free to shoot us an email at weatheredquestions@gmail.com. You can leave us a review, tell your friends and family, all of those things. Again, great ways to support the show. And we're so thankful for those of you that do that. Until next week, stay safe.